Welcome to this deep dive on the AI brief. We're cutting through a lot of noise this week to bring you what we see as the really core breakthroughs in accelerated computing and, well, scientific automation.
It feels like we're watching a fundamental shift, not just in how we compute things, but in how science itself might get done.
Absolutely. So our mission today is to unpack three genuinely giant updates. First, there's this AI scientist called Kosmos. It's pushing the limits of autonomous discovery.
Right. Then there's a really stunning breakthrough in using light waves for super fast tensor computing.
And finally, we have to talk about NVIDIA. They just completely swept the latest MLPerf benchmarks, and we need to look at what that dominance really means.
Then we've also got some major developments from space, physics, even ancient biology. And we'll wrap up with the trending AI tools you can actually use right now.
Okay, let's get into it, starting with Kosmos from Edison Scientific. The name AI scientist, that's a big claim. It suggests we're moving past the AI as just a research assistant.
It is a big claim. It means the AI can, set its own research goal and then actually pursue it coherently across just massive amounts of information.
So what does that mean in practical terms? They're saying it can speed up discovery by what, 6 months of human labor?
6 months, yeah. And the way it does that is it uses something they're calling structured world models.
Okay, that's the term we need to break down. What exactly is a structured world model? Because most AI systems, they tend to lose focus when you're talking about millions of tokens.
Exactly right. A world model here is basically an internal structured map of the scientific field it's looking at. So it's hypotheses, its key findings, its methods.
And Cosmos uses that map to stay on track.
It uses that map to stay on track to avoid the kind of hallucinations or, the conceptual drift you see in a standard LLM. And the scale is what's just mind-boggling. In one run, it can ingest 1,500 scientific papers.
1,500.
And execute 42,000 lines of code, all while keeping that one complex goal in mind.
The potential for drug discovery in material science is pretty obvious. But let's talk about the elephant in the room. Accuracy. They're claiming 79.4% accuracy in fields like genetics or neuroscience, and nearly 20% error rate. Sounds risky.
It is the critical question for sure. And while almost 80% is frankly remarkable for an autonomous system, that other 20%, it still requires intensive human verification.
So there has to be a safeguard.
There is. And the saving grace here is the system's transparency. Every single conclusion it generates, you can trace it right back to the specific line of code or the exact sentence in a paper that it used.
Okay, so it's not a black box. It's more of a verifiable scientific co-author.
Precisely. It accelerates that initial discovery phase, but a human scientist still has to come in and do the quality assurance, audit the findings.
Right. And what about access? It's $200 per run. Does that limit it to just the big pharma companies?
Initially, yes. It's definitely geared toward well-funded R&D. But they do have a free tier for academics, and that's really meant to drive adoption in university research. I think the bigger picture here is the AI is moving from being a research tool to an autonomous author.
That's a huge shift. Now, here's where things get even more interesting, because this isn't just about the science. It's about the fundamental limits of computation itself. Researchers at Aalto University seem to have found a way to just bypass all the normal electronic limits.
This is a huge step for AI infrastructure. They figured out how to do these really complex tensor operations, the absolute mathematical core of deep learning, not with electricity, but with a single pass of light.
A single pass of light through an optical system. So calculations are happening, simultaneously at the speed of light?
Yes, simultaneously. And the big benefit beyond just the speed is the energy efficiency. You completely get around the whole energy-intensive process of electronic switching.
How does that actually work? How do you compute with light?
Well, they encode the digital information directly into the light wave itself, into its amplitude and its phase. And the system is passive.
No electronic switching at all?
None. What's so clever is how they get the complexity from modern AI. For these higher-order tensor operations, they just use multiple wavelengths of light at the same time. Each color is basically handling a different data dimension in parallel.
That is a brilliant way to think about it. So this isn't some far-off 50 years from now technology. What's the timeline look like?
The researchers are pretty optimistic. They think it could be integrated into photonic chips and, put into existing hardware within maybe 3 to 5 years.
3 to 5 years. That's what we'll need if we want AI models to keep growing at this exponential rate.
It's the only way to overcome the electronic bottlenecks.
Okay, so moving from the lab to the market, we have to talk about NVIDIA's performance. They just ran the table in the latest MLPerf Training benchmarks.
ran the table is a good way to put it. I mean, it was a total sweep. All 7 tests, fastest time to train across every single major category, LLMs, image generation, you name it.
And this was all driven by their new Blackwell Ultra architecture. We keep hearing this headline number, a 4-time speed up over the last generation Hopper. What's the real takeaway there?
4 times in a single generation is just, it's astounding. But the real implication is how aggressively they're driving down the cost curve. Training these huge models or doing complex inference at scale, it just becomes exponentially cheaper and faster.
So for everyone else trying to compete, NVIDIA is basically resetting the bar every 12 months.
They are setting the pace for the entire industry. Now, they're touting 15 petaflops of NVFP4 compute.
Right. Can you break down what NVFP4 precision is?
Sure. So NVST4 is a 4-bit precision format. Most models use higher precision, like 16-bit. Using 4-bit lets you pack data way more compactly, which massively increases the throughput on the chip.
And when you combine that with all the other new hardware.
Exactly. You combine that with almost 300 gigs of HBM3E memory, and you get these record-breaking runs on models like Llama 3.1 405B. It's this continuous, rapid advancement that's really driving AI adoption everywhere.
All right, let's transition now. We're going to slow the pace down just a little bit here and look at some of the other really stunning achievements happening across science and engineering.
Starting in space, Jeff Bezos' Blue Origin, they hit a major milestone. They finally landed the reusable booster for their new Glenn rocket on an ocean barge.
And this is a huge technical achievement. I mean, we see SpaceX do this almost routinely now, but successfully landing a massive rocket booster on a moving target at sea, that is incredibly difficult. It's a major win for them.
Definitely. And now, moving from engineering back to physics, scientists just validated a 70-year-old hypothesis that could enable Mach 10 travel.
Mach 10. So what did they find that suddenly unlocks that?
They discovered that turbulence at extreme speeds, so at Mach 6, behaves in a surprisingly similar way to much slower airflow.
And that similarity makes it easier to model.
It makes it computationally feasible to design the planes. So what was once a theoretical impossibility is now something we can actually simulate and design. We're talking about 1-hour flights to anywhere on Earth.
That is true time-space compression. Amazing.
And then, looking way beyond our planet, researchers with the Very Large Telescope in Europe, they caught something incredibly rare.
A supernova.
The very earliest stages of one. They captured it just hours after the material first burst through the star's surface.
That must be so difficult to time. What does an observation like that tell us?
It's so powerful that it's already ruling out some existing theories about how these cosmic explosions actually start. It's forcing a real reassessment of fundamental stellar physics.
And finally, let's look back in time. 39,000 years, to be specific.
With the recovery of the oldest RNA ever found, researchers pulled it from a woolly mammoth that was preserved in permafrost.
And RNA is so important because, unlike DNA, it captures what the cells were doing in real time, right?
Exactly. DNA is the blueprint, but RNA shows you which genes were active, what was being turned on and off when that mammoth was alive. It's an unprecedented snapshot of Ice Age biology.
So this could open up whole new ways of studying ancient life.
It suggests RNA can survive way longer than we thought, if the conditions are right. It's a huge deal for paleobiology.
Absolutely fascinating stuff. Okay, let's pick up the pace again and jump into the trending AI tools that can help you in your daily workflow.
All right, we put together a list focused on automation and specialized intelligence. First up for your inbox is Oskar by Scarb. It's an AI agent that handles automatic follow-ups in your email.
For anyone working with international teams, there's Talo. It's an all-in-one AI translator for calls, events, and it even has an API.
Next is the SED 3.0. They're calling it the Everything app for feedback, so a tool for gathering and making sense of customer data.
And for people in the AI space who want to monetize their work, check out Passion Fruit Labs. It's designed to turn mentions and citations of your work into revenue streams.
If you're into health and diet, there's Emma. It's an AI nutrition intelligence tool that understands food composition globally. Very personalized.
For HR departments, there's Sensei AI Offboarding. Its job is to capture knowledge from employees who are leaving, which minimizes paperwork and knowledge loss.
For creative professionals, we'd recommend YouArt. It's described as an agentic workflow studio, specifically for creating high-quality creatives at scale.
And lastly, for the enterprise level, there's MindPal. This is a multi-agent system for building and running entire AI teams to handle complex business processes.
That's a pretty powerful list. It covers everything from your personal inbox to full enterprise automation.
And that wraps up this deep dive. We've gone from autonomous AI scientists like Kosmos to the future of light-speed computing and the incredible pace of NVIDIA's hardware.
It really feels like the foundations are shifting. The computational engine and the methods for discovery are both changing at the same time, and that convergence is redefining what's possible.
If you found this deep dive valuable, please make sure you follow the show and share it with colleagues and friends who need to stay on top of these changes.
See you in the next deep dive.